Hello. Now here we will start the lecture 2 based on amines. So in the previous lecture we have completed the classification and the nomenclature. Now we will start with the preparation. Now if you will see the preparation of the amines, the first preparation is from NO2 group, that is a nitro group. And when the nitro group you want to be convert this into amine, that is NH2 group, we have to use the reducing agent. And reducing agent you have done in the previous alcoholic chapter, aldehyde and ketones chapter also. That is the palladium in the presence of hydrogen. You can take the platinum or nickel in the presence of hydrogen, or you may take the tin and HCl or iron and HCl, metal in acidic medium. They will also responsible for the reduction of NO2 group into NH2 group. So whenever the NO2 group is present, whatever it is aliphatic or aromatic ones, it will result in the formation of aliphatic amines or aromatic amines. That is primary amine you will get by using this reducing agent. Any one of the reducing agent we can use in this reaction to convert NO2 into NH2. Now another, in the reducing agent you will take the cyanide group. Cyanide group is nitrile group, and we can use the lithium aluminum hydride, nickel platinum H2, palladium H2. So that will be results in the formation of, that is C triple bond N. When the nitrile group is there, C triple bond N group is there, so that will be converted into CH2 NH2, and we will get the primary amine by using this cyanide group. So whenever you are having, suppose you are having the benzonitrile group, so you may write that suppose you are using lithium aluminum hydride over here, so you will get the benzyl amine, that is C and N. They will remain intact with each other and they will give rise to the formation of primary amine. Now suppose you are having NC, that is isonitrile. In that case, you will get the secondary amine, that is NH and CH3 group. That is, this carbon is converted into CH3 and this nitrogen is converted into NH group, and you will get the secondary amine by using this isocyanide group. So whenever you are having the nitro group, you can do the reduction, cyanide, you can do the reduction, and you will get the corresponding primary or the secondary amines. Now the another group which is used for the preparation of amines are the amide group. In case of amide, again there is C double bond O group is present, and this C double bond O group, amide, C double bond O group is present. So this C double bond O group will be converted into CH2 group, again in the presence of lithium aluminum hydride or the reducing agent we can use, and that will be converted into CH2 NH2. Suppose you are having benzamide. Now this is the structure of benzamide, which is converted into benzyl amine. So the three functional groups are there, nitro, cyanide and the amide, which on reduction give rise to the formation of primary amine or the secondary amine. Another preparation of the amines are the ammonolysis process. Ammonolysis process is the process in which we are adding the ammonia, that is addition of ammonia, and the alkyl halides we have to take like RCl. Now if we want to make the CH3NH2, अगर हमें बनाना है methyl amine, so we have to take the CH3Cl, that is CH3Cl group we will take, and then this results in the CH3Cl and then ammonia, that will give rise to the formation of primary amine like this. Methyl amine you will get. Now here is the removal of HCl molecule takes place, that is HCl will be goes from here and hydrogen from there, and will give rise to the formation of this primary amine. After that, one more molecule of CH3Cl can be attack on it, and it give rise to the formation of secondary amine. Likewise, there is a formation of tertiary amine. We have to write the tertiary amine in this manner. So you can see there is a formation of mixture of primary, secondary, tertiary amines. Since there is lone pair of electrons present on the nitrogen atom, so one more alkyl group can also be attack on it, and it give rise to the formation of quaternary ammonium salt. ये बन जाएगा. Quaternary ammonium salt formation will be there. So you can easily understand there is a formation of primary amine, secondary amine, tertiary amine, and quaternary ammonium salt. This kind of the preparation takes place in case of ammonolysis. Means we are getting the mixture of the amines, not the pure primary amine. So this method is not the good method for the formation of pure primary amine, as we are getting the mixture of primary, secondary, tertiary, and quaternary ammonium salt. So this question can be asked in the examination, that why the ammonolysis is not a good method for the formation of pure primary amine. Now there is a method by which we can prepare the pure primary amine using alkyl halide, and it is nothing, it is a Gabriel thalamide synthesis. Now see how does it takes place. In case of Gabriel thalamide synthesis, you will take the Gabriel thalamide molecule. This is the thalamide molecule, which is obtained from phthalic acid. Phthalic acid is benzene 1,2-dicarboxylic acid, dioic acid, benzene dioic acid. So whenever it will react with the ammonia, it will give rise to the formation of thalamide. This thalamide will be formed. So we are using this thalamide here. It will react with an alkali KOH or the NaOH. Since KOH is more basic in nature, so we are taking KOH, and this hydrogen atom will be acidic in nature because there is two carbonyl groups are present, which has a tendency to take the electrons from the nitrogen atom, and it can easily replace the hydrogen atom. So we can say that this hydrogen atom is acidic in nature in case of amides. So because of this acidic behavior, there is a formation of potassium salt. That is, potassium salt of thalamide will be formed in the first step. And after that, depending upon what type of the amine we want to be get, we have to take the alkyl halide over here. Like if you want to make the primary methyl amine, you can take CH3Cl. Ethyl amine, you can take C2H5Cl. Benzyl amine, you can take C6H5CH2Cl over here. So the K and Cl, they will remove together, and there is a formation of an alkylated thalamide. An alkylated thalamide will be formed, which on basic hydrolysis give rise to the formation of pure primary amine from this structure, and we are getting the sodium salt of phthalic acid from this structure. And here you can easily understand the two sides of the nitrogen atom are blocked. ये दो sides block हैं, so nothing can be attached over here, so that we are getting the pure primary amine. Now the aniline cannot be prepared from this process. Means aromatic compound cannot be prepared from this process, because for the aromatic amine here we need the chlorobenzene, which are unreactive because of resonance stabilization. So aromatic amines cannot be prepared by using Gabriel thalamide synthesis, and it is a very good method for the formation of pure primary amine. Now the another method for the formation of amines are the Hofmans-bromide reaction. In Hofmans-bromide reaction, we have to take the amide in the presence of bromine and NaOH. It gives rise to the formation of a amine which has one carbon atom less than the parental amide. जो CO group है, it will be get removed, and that will be converted into Na2CO3. And there is a formation of primary amine having one carbon atom less. Now suppose you are having ethanamide. ये हमारे पास ethanamide है. And when we are adding Br2 or NaOH, Br2 in the presence of NaOH, it can also be written as like this NaOBr. ये भी लिखा हुआ मिल सकता है NaOBr. It gives rise to the formation of, what will happen? This CO group will be completely removed and we will get CH3NH2. हमारे पास methyl amine आ जाएगा. And the rest are the side products. You may write the side products from there, but the main product will be correct, otherwise you will not get the marks. Now suppose you are having benzamide or you are having benzyl amide. This is benzylamide. ये हो गया. If you are adding NaOBr to it, then you can easily understand now this CO group will be completely removed and there is a formation of benzylamine. Means the one carbon atom less than the parental amide. So these are the methods by which you can prepare the pure primary amines. Now we will discuss about the physical properties of the amines. Now during the physical properties, first of all, we should know what sort of intermolecular force exists between them, since amines are polar in nature, because again they are having the nitrogen atom which is electronegative in nature. So that the amines are polar in nature and these are soluble in water due to the formation of hydrogen bonding. And this hydrogen bonding leads to the greater solubility of the amines in water. But the lower amines are soluble in water and the higher amines are insoluble, or the solubility decreases as there is a increase in the carbon atom. जैसे जैसे carbon atom increase होंगे, so there will be decrease in the solubility. See how does it takes place? Now suppose you are having RNH2. As the R group increases, suppose you are having methylamine and ethylamine. So methylamine is more soluble in water as compared to ethylamine, because in case of methylamine, R group is there which is not but more bulky in nature. And this ethylamine is more bulky than CH3, so it will increase the non-polar character. So if the non-polar character increases, so the solubility will be decreases. So we can say the higher amines are less soluble, partially soluble or insoluble in water. Aniline. Suppose you are take the example of aniline. Aniline is insoluble in water. It is because of the reason, in case of aniline, there is a benzene group present. That is phenyl group present, and it has the high non-polar character. And because of this non-polar character, it makes the aniline to insoluble in water. Now, if we are comparing the solubility of primary, secondary and tertiary amines. Now it is very much clear to you that primary amines are more soluble in water than secondary than tertiary, because of the extent of hydrogen bonding in primary is more, as the primary amines will contain the two hydrogen atoms which has a tendency to make the hydrogen bonding. In case of tertiary amine, there is only lone pair of electrons are present which get protonated and forms the hydrogen bonding. Now, if you are taking the alcohols and amines, both are soluble in water. But if you are comparing the solubility of these two, then you can easily understand that alcohols are more soluble in water, because the hydrogen bonding made by alcohols is stronger as compared to amines, because oxygen is more electronegative than nitrogen atom. So this was all about the solubility. Now next is the boiling point. Boiling point of amines is again very high due to the hydrogen bond formation. But this boiling point is less as compared to alcohols, as in the previous statement we have seen that oxygen is more electronegative in nature, so it forms the stronger hydrogen bonding as compared to nitrogen. So alcohols have the high boiling point as compared to amines. Now we will discuss about कि primary, secondary, tertiary amine में which has the high boiling point. So it is but obvious that primary amines makes the stronger hydrogen bonding because of there is no steric hindrance. Secondary and tertiary. In case of tertiary amines, there is 3 R groups. In case of secondary amines, there is 2 R groups. In primary, there is 1 R group is present, and it will causes the hydrogen bonding less because of steric hindrance and the absence of hydrogen bonding. Now, another topic is the basicity of the amines. That is, how does the amines shows the basic character and why? Amines are basic in nature. It is very obvious statement, because in case of amines, the nitrogen atom has a lone pair of electrons which has a tendency to form the salt with the acid, so that it will form this kind of the salt, and this indicate that it is basic in nature and these are acidic in nature. So we can say all the amines are Lewis basic in nature, and they also has a tendency to form the complexes with the transition element, like coordination compounds can be prepared by using this NH3 like NH3 suppose this kind of the complex, or they can also forms this kind of the complex with the amines. इस तरीके से भी complex बन सकता है, and these are the coordination compounds that we will see in the part 1 coordination compound chapter. So amines are Lewis basic in nature. It is clear to all of you now. Now we will consider one by one ki how does the basic nature affected by the various groups, and which are more basic and which are less basic in nature. So first of all, we will discuss about primary, secondary and tertiary amines. That is in the gaseous phase. Now here you will see, in case of primary amines, there is one R group present. In case of tertiary secondary amines, there is two R groups present. In case of tertiary amines, there are three R groups present, like this. Now, R group always shows the plus I effect, means they considered as electron donating groups. And electron donating groups always increase the electron density around the nitrogen atom. So, 1 plus I effect, there is 2 plus I effect, and there are 3 plus I effect are present. So, it is very obvious that tertiary amines are more basic in nature as compared to secondary and primary amines. So, it is very clear that as the number of electron donating group increases, the basic nature will be increases. Now, if we will compare with the aromatic amines and aliphatic amines. Aromatic amines are aniline, and the aliphatic amines you can take anything, like you are taking methylamine. Now here you can easily understand that CH3 group shows the plus I effect. Now if we will consider this benzene ring, so you can easily understand, in case of benzene ring, the lone pair of electrons will be get resonance structure with this ring, and there is a formation of such kind of the resonating structures will be there. What does these structures indicate? These resonating structures indicate that lone pair of electrons are not available for donation, and the basic nature will be decreases. So you may say that the aliphatic amines are more basic in nature as compared to aromatic amines, or whenever the aniline compounds are there, they are less basic in nature as compared to aliphatic amines. Now, if we will take in terms of Kb and pKb, so see very carefully about this. Kb means dissociation constant for base, and pKb is minus log of Kb. So whenever the dissociation constant for Kb is more, means high value of Kb indicate more basic nature. And the reverse is true for pKb, that is, as the pKb value is low, then it is more basic in nature. So these two values must be clear to all of you, that how does they will be related to the basic nature of the amines or any basic in nature. Now, if you will take, if the benzene ring is there, and you will take kind of the molecule in which, suppose you are having N-methyl aniline, and you will take benzyl amine. ये benzyl amine है. Okay. Now, if you will see the basic nature of these three compounds, so you can easily understand these two undergoes in resonance, but there is no resonance takes place in this molecule. So you can say CH2, KH2, it has the highest Kb value, means it is more basic in nature. And among these two, there is CH3 group present, which is electron donating group. So it will increase the electron density around the nitrogen atom, and it is more basic in nature as compared to aniline. So in that manner, you can compare the basic nature of any of the molecule in the gaseous phase. Now, if we will see the basic nature in case of aqueous solution. In case of aqueous solution, the two examples are there. One is the methylamine, like primary, secondary and tertiary methylamine. The nature, the basic character will be in this order. That is secondary, primary and tertiary. So that means it indicates not only the plus I effect is there, which will decide the basic nature in the aqueous solution. Since there is a solvation effect also entered, because the solvent molecules are surrounds the amine molecule. So according to the plus I effect, you know well, tertiary amines are more basic in nature as compared to secondary, as compared to primary. But whenever the solvation effect also entered, the primary amine will be more solvated. Primary amine will be more solvated means more and more H2O molecules will surround the nitrogen atom in this manner. So that the combined effect of plus I effect and the solvation effect will give rise to the basic nature in this order, that is secondary, primary and tertiary. Now, the another is the ethyl amine. Ethyl amine, there is a little bit change, that is secondary, tertiary and primary, because of the reason that is plus I effect is there, solvation effect is there, but the one more effect is in the consideration also, that is the steric effect. Steric effect. Steric effect means that two CH2 molecules are there which are bulky in nature, and they will be changed the basic order in this manner, that is secondary, tertiary and primary. Okay. Now, see what is the effect of the substituent on basicity. It is just reverse of the acidic behavior, that is electron donating group will increase the basic nature, because electron donating group will increase the electron density around the nitrogen atom, like OCH3 group. You can take the alkyl group, you can take the OH group, you can take the NH2 group. All these will increase the basic nature. Now, whenever the electron withdrawing groups are present, like NO2 group present hai, like cyanide group present hai, like CHO group present hai, any one of the group will be there which are electron withdrawing in nature, they will decrease the basic nature. You can see that is the aniline and toluidine. Toluidine means there is CH3 molecule present along with the NH2 molecule. So it is electron donating group. So aniline will be less basic in nature and toluidine will be more basic in nature. So this is the ortho isomer of toluidine. So in that manner, you can compare the basic nature of the various compounds. So here we have discussed about the basic nature and the preparation of the amines. So in the next lecture, we will continue this chapter, do the NCERT questions till then.